Hello everybody. Today, I'll be presenting my term project written in Python and edited in Canopy. My term project is a Roomba simulator, and the Roomba is a small yet efficient robot used to vacuum the floor. You can first select a standard room and view the standard simulation. The user can click on robot movement at any time to view the 5 different types of movements, as well as how the robot cleans the room in each type of movement. You can also click on the help button to look at the different key press buttons that toggle each movement respectively. You can begin by pressing P for spiral movement and G to go. And the type of movement is shown here, spiral movement, together with the data about the robot, such as its radius, speed, direction, and position. So in the spiral movement, the robot slowly turns clockwise and moves outwards to clean the floor. You can also switch to a standard movement anytime, where the robot moves in a straight line, and when it reaches a boundary, it chooses a new direction to clean the floor in. You can have a manual movement. The user can press left and right arrow keys to change the direction of the robot. A random movement is when the robot changes its direction after every time step, and this is designed to be the most inefficient method, as opposed to the optimal movement, where the robot scans the entire floor. It searches for pixels that are dirty and cleans them systematically, starting from the ones closest to itself. And eventually, the robot will clean the entire floor. You can reset, go back to standard room and view the graph plotting mechanism. You can enter a number of trials and select a variable for graph to be plotted against. So in this case, you have a plot of time taken against number of robots. And we see that the random robot in green is the most inefficient, while the optimal robot in red cleans the room the fastest. And as the number of robots increase, the time taken decreases. You can repeat this with a different number of trials and a different variable, such as robot speed, and generated graph follows almost the same pattern. You can also choose to not graph it and just enter the variables, such as one robot, size 5, speed 5, and one trial, moving optimally by pressing O, and the program runs the simulation and returns the amount of time taken to clean the floor, without having to view the entire simulation. The second feature is a customized room, where the user can follow a sequence of steps to create their own room and clean it. You can first join the dots to define a room boundary with undo and redo functions, add a bed with resizing abilities, as well as undo redo functions. Press next and press the spacebar to confirm the room, and it will be filled with 30 pixels. You can then add a number of people, such as 2, and these randomly moving people are designed to be avoided by the robots. You can then add 2 robots and watch them clean the floor in the standard movement by pressing S. So these 2 robots will recognize the boundaries of the room and the boundaries caused by the furniture, and only clean the room within these boundaries, rebounding off the walls when it reaches a boundary. You can also select a different movement type, such as spiral, which does the same thing as in a standard room. You can change it back to standard, and you can also view the different types of data about both robots. So now robot 1 is highlighted, this is its data. You can change it to robot 2, and it shows the data of this robot. And you can change it to optimal, where these 2 robots will completely clean the room optimally. And that is the end of my term project. Thank you for watching, and have a good day.